Welcome back to my channel. I don't think people understand how even the most sophisticated AI models can harbor biases that skew their results and lead to unintended consequences. These biases can creep in at various stages of the model development process, from data collection to algorithm design, and even during deployment. Understanding and mitigating these biases is crucial for creating fair and accurate AI systems. Think again, it might be biased. Bias in AI models can manifest in many ways, and it's not always easy to spot. Sometimes the bias is subtle, lurking beneath the surface, affecting the model's predictions in ways that aren't immediately obvious. Other times it's glaringly apparent, leading to results that are clearly skewed or unfair. Either way, it's a problem that needs to be addressed. Let's break down model biases in 60 seconds. First up, data bias. Data bias occurs when the data used to train the model is not representative of the real-world population it's meant to serve. This can happen for a variety of reasons, such as collecting data from a limited demographic or using outdated information. When a model is trained on biased data, it will inevitably produce biased results. Imagine training a model with only cat pics. It'll think dogs don't exist. That's sampling bias. Sampling bias occurs when the data sample used to train the model is not representative of the entire population. For example, if you're training a model to recognize animals but only use pictures of cats, the model will struggle to identify dogs, birds, or any other animals. This type of bias can severely limit the model's effectiveness and accuracy. Or picking data that confirms your beliefs. That's confirmation bias. Confirmation bias happens when the data selected for training the model is chosen in a way that confirms pre-existing beliefs or hypotheses. This can lead to a model that reinforces existing stereotypes or misconceptions, rather than providing an objective analysis. It's important to be aware of this bias and strive to use diverse and representative data sets. If your algorithm is flawed, so is your model. Algorithmic bias occurs when the algorithms used to train the model are inherently biased. This can happen if the algorithm is designed in a way that favors certain outcomes over others, or if it's based on biased assumptions. To mitigate algorithmic bias, it's important to use transparent and fair algorithms, and to regularly test and validate them to ensure they're working as intended. Picture trying to fit a square peg in a round hole. Optimization bias. Optimization bias occurs when the model is optimized for certain metrics at the expense of others. For example, a model might be optimized for accuracy, but this could lead to a trade-off in fairness or interpretability. It's important to strike a balance between different metrics and ensure that the model is not overly optimized for one at the expense of others. Humans aren't perfect, and our biases sneak into models. Cognitive bias is another important factor to consider. Cognitive bias refers to the biases that humans bring to the table when designing and training AI models. These biases can be based on personal experiences, cultural background, or even subconscious preferences. It's crucial to be aware of these biases and take steps to minimize their impact on the model. Anchoring bias is like getting stuck on the first idea you hear. Anchoring bias occurs when the first piece of information encountered influences subsequent judgments. In the context of AI, this can happen when initial model results or hypotheses unduly influence the evaluation process. It's important to approach model evaluation with an open mind and consider multiple perspectives to avoid this bias. Using skewed metrics can warp your model's accuracy, leading to model evaluation bias. This type of bias occurs when the metrics used to evaluate the model are not appropriate or are skewed in some way. For example, using accuracy as the sole metric for a model that deals with imbalanced data can lead to misleading results. It's important to use a variety of metrics and ensure they're appropriate for the specific use case, like judging a fish by its tree climbing skills. Finally, deployment bias. Deployment bias occurs when the model is deployed in a different environment than it was trained in, leading to unexpected results. For example, a model trained on data from one region might not perform well when deployed in a different region with different characteristics. It's important to consider the deployment environment and ensure the model is robust and adaptable. If updating your model is biased, its future predictions will be too. Regular updates and maintenance are crucial for keeping the model accurate and fair. However, if the updates themselves are biased, they can introduce new biases into the model. It's important to have a rigorous update process and regularly review the model's performance to ensure it remains unbiased. To fight bias, use diverse data, unbiased algorithms, and involve a diverse team in the model development process. Diversity in the team can bring different perspectives and help identify potential biases that might be overlooked otherwise. It's also important to use diverse data sets that represent the real-world population and to use transparent and fair algorithms, and keep your evaluations straight. Regularly review and update the evaluation metrics to ensure they're appropriate and fair. This can help identify any biases that might have crept into the model and take corrective action. It's also important to involve stakeholders in the evaluation process to get a comprehensive view of the model's performance. Your models will thank you. By taking these steps, you can create fair and accurate AI models that serve their intended purpose without introducing unintended biases. Remember, the goal is to create models that are not only accurate but also fair and unbiased. Your efforts will be rewarded with models that perform well and are trusted by users. Additional tips to mitigate biases include conducting regular bias audits, using fairness-aware machine learning techniques, and incorporating feedback loops to continuously improve the model. Bias audits can help identify and address biases at various stages of the model lifecycle. Fairness-aware techniques can adjust the model to ensure equitable outcomes. Feedback loops allow for ongoing monitoring and adjustment, ensuring the model remains fair and accurate over time. By implementing these strategies, you can build AI models that are not only effective, but also ethical and trustworthy. The journey to unbiased AI is ongoing, but with diligence and commitment, it's possible to create systems that truly benefit everyone.